In this example, we're going to use the Gram-Schmidt algorithm to find an orthonormal basis for vectors u1, 1, 1, and u2, 2, 1. Okay, so the first thing we want to do is we want to find vector e1, which is a normalized version of u1. So it's 1 over the length of u1 times u1. Now the length of u1, 1 plus 1 is 2, so root 2. So we have 1 over root 2 times the vector 1, 1. Excellent. Now that's our first vector from our basis, from our new basis. Okay. Our second one, we're going to construct by taking u2 and removing everything that's in e1. So we need to find the projection of u2 on e1. So the projection onto e1 of u2 is equal to u2 dot e1 over length of e1 squared times e1. Okay. So we can do a little bit of arithmetic here. So the length of e1 is 1. So this goes away. u2 dot e1 is 2, 1 dotted with e1, which is 1, 1 times that multiplier 1 over root 2. So I'll just swap it out by dividing by root 2 times e1, which is 1 over root 2 times 1, 1. So this dot product here is 2 plus 1 is 3. Root 2 times root 2 is 2 times vector 1, 1. So we have 3 halves times vector 1, 1 is the projection of u2 onto e1. And so we can figure out the orthogonal projection, or what we call W2, is u2 minus that projection. So this is 2, 1 minus 3 halves, 1, 1. So we've got 2 minus 3 halves. So that's 1 half. Then we have 1 minus 3 halves, which is negative 1 half. And then, of course, we've got to normalize this. That's our E2. So E2 is 1 over the length of W2 times W2. Okay, the length of W2 is a half squared plus a half squared, so that's a quarter plus a quarter, so that's a half. And so we end up able to rewrite this as 1 over root 2 times 1 negative 1. Right, so we have a half squared, which is a quarter, plus another quarter. So that's 2 quarters, so a half. So that's root of a half. 1 over root of a half is 1 over root 2. Okay, so our orthonormal basis then it's the vector 3 halves times 1, 1. And the vector, oh, that's not true. It's the vector 1 over root 2 times 1, 1. And the vector 1 over root 2, 1, negative 1. And of course, those are unit length. You can see that. And if you draw a quick little graph, you can see that those are also perpendicular to each other.